What role does scale factor play in cartography? Imagine trying to fit the entire world onto a piece of paper. It's a tricky task because the Earth is round, but maps are flat. That's where the idea of scale factor becomes really important. In geometry, scale factor is a number that shows how much bigger or smaller one shape is compared to another. If you have two similar triangles, for example, every side in one triangle is multiplied by the scale factor to get the corresponding side in the other. If the scale factor is 2, then every side in the second triangle is twice as long as the first. Now think about maps. When cartographers make a map, they shrink the real world down to fit on paper. The scale factor in cartography tells us exactly how much smaller the map is compared to real life. For example, if a map has a scale of 1 to 10,000, then 1 centimeter on the map equals 10,000 centimeters in the real world. That's 100 meters. But here's the interesting part. The Earth is a sphere, and maps are flat. When you try to flatten a globe, some shapes, angles, and distances get distorted. That's why the scale factor isn't always the same everywhere on a map. It changes from place to place, depending on the map projection used. This variation is called the point scale or local scale factor. For small areas like a neighborhood or a city, the scale factor stays pretty much the same across the map. You can use one scale factor to measure distances accurately. But for larger areas like a continent or the entire world, the scale factor varies because of the way the map projection distorts the shape. Some projections try to keep angles correct, which is useful for navigation, while others focus on preserving area. No map can do both perfectly. Let's say you're planning a bike trip using a map with a scale of 1 to 50,000. That means 1 centimeter on the map equals 500 meters in real life. You can use that to estimate how far you'll ride. But if the map covers a large region, the scale factor might not be exactly the same everywhere, so your distance estimates could be a little off. In geometry, similar shapes are related by a scale factor that tells you how much bigger or smaller one shape is compared to another. In cartography, the same idea applies but on a bigger scale. Instead of comparing to shapes, you're comparing the map to the real world. The scale factor shows how much the map shrinks reality and where that shrinking isn't uniform. In summary, the scale factor in cartography is the key to understanding how distances on a map relate to real distances. It's a simple idea from geometry, but because the Earth is round and maps are flat, it gets a bit more complicated. Knowing the scale factor helps you read maps more accurately, whether you're measuring the size of a park or planning a cross-country trip. It's the bridge that connects what you see on the map to what's really out there in the world.